Hello, my name is Gyanendra, and today we are going to discuss about propositional logic and various concepts using Python language. So, as you can see on the screen, propositional logic, it is the simplest form of logic. The only statements that are considered as propositions are which contain no variables. They are either true or either false, like 2 plus 2 is equal to 4, and it is always true and has no variable in it, so we call it a proposition. Similarly, 2 plus 2 is equals 5, and it is also a proposition since it is false and has no variable. But there is an exception. X into 0 is equal to 0. As we all know, it's always true, but it will not be considered as a proposition because it has a variable x in it. There are various operations that we perform on proposition statements, the first one is negation. The negation of p is written as like this, and it has the property that it is false when p is true and true when p is false. So it just acts opposite as the input is given. And the second one is or. The or of two propositions p and q is written like this and is always true as long as at least one of them is true. In coding terms, we use the straight line to represent or, and and of p and q is written as p like this and is true only when both p and q are true at a time. And in coding terms, and is represented by the and. Implication, and implication represents then if this then this. So for example, if p implies q, then we mean by that q is true whenever p is true. Similarly, we have a biconditional statement, p implies q and q implies p. This means that both p and q are either true or both p and q are false. The only way p and q is false will be like one side needs to be true and one side needs to be false. P needs to be true and q needs to be false in order to make p both implies q as a false statement. So contradiction, a compound proposition is called contradiction if and only if it is false for all possible truth values of its propositional variables. It contains only f in last column of its truth table. So basically, whatever we give the input, it's always false. Now let's talk about tautology. Tautology, it's a compound proposition and it's true no matter what the truth values of the proposition. It means whatever may be the input, the output will always be true. So now let's talk about contingency. A compound proposition is called a contingency if and only if it is neither a tautology nor a contradiction. It contains both true and false in the last column of its truth table. So basically, most of the propositional statements will be contingency and not contradiction or tautology. There will be a specific case or a few of the propositional statements which will be tautology or contradiction. So now let's work with all these logical statements and coding part. So we are working in Python ideally. So in order to work with logical statements, we need to import logic and logic import star. So basically we are importing a module by the name logic, and the second statement will import all its function. Let's let me tell you that for understanding this video, you all need to have prior knowledge of both Python and about the logic statements. So now I will make P, Q, and R as the three propositional variables using vars function, and this is the way we do it. Sorry. Okay, so as we can see, using this was function, p, q, and r are the propositional variables. So if I write p and press enter, so it's telling us proposition p. Similarly, if I write q, then it will show proposition q, and r and proposition r. We can say that the main use of this logic module is that we can use it to visualize a truth table. So instead of making it by hand, we can just put the operation as a formula, and we will get the output. For an example, I make formula a is equals p and q, and use the function for making truth table, print underscore truth underscore table, and press enter. So we can see the truth table as the output. Similarly, we will work for different operations, like let's pick another formula, b is equals p or q, and b dot print underscore truth table, and we have the output as it in the form of a truth table. Let's make truth table of a negation statement, and let's name it c is equals p. So you should know that the negation statement and the negation sign is written like this, and let's write print underscore truth table. So if the input will be true, then the output will be false, and if input is false, then the output will be true. Similarly, let's make a truth table for the implication statement. Like let's name it D, and P implies Q. Okay, so D dot print truth table, and okay, so as we can see the output, it's in the form of truth table. Now let's test it this for a bit complicated formulas. So let's name it sorry so let's make it like formula 1 2 equals inside the bracket p and q, and let's say implies r. So this is the formula, and let's make the truth table. Sorry, it's print underscore truth underscore table, and let's print it. As we have seen that this will be the output. So now let's test whether it is a tautology or not. So in order to test it, we have a function like is tautology. So we will write it like formula dot is underscore tautology. So there was a spelling mistake in this. So is tautology and bracket and false. Since we know the definition of tautology, that the output will be always true, whatever way we want to give the input. So as the second one, we can see that it was false, so it's not a tautology. Similarly, to check that it's a contingency or a contradiction, we have similar functions like formula dot is underscore contingency and brackets and is showing true. Similarly, it's like formula dot is contradiction false. So now let's try it for a bit more like a real complex statement. So let's name it formula 2 and sorry numlock. Okay, so uh, inside let's write p or q and sorry p or q and negation p also implies q. So it's a bit complicated, and now let's print the truth table for this one. Formula 2 dot print underscore truth underscore table bracket, and this is the output. So this is how we work with various logical statements, and the way we can get truth table as the output. So this is all, and thank you for your time. Like, share, and subscribe. Jai Hind.